Hi, my name is Sophie. I'm making another video. Um, I was sent this GIF of a cat. Um, it's a silly cat image, but it has these colors on it. And I was thinking about like how you would make this, and I don't know how to make it, but I'm kind of wondering like how does this happen? So I wanted to try to like make it in Python. The music is Picross E plus 3D OST on YouTube. I guess I'll put a link to that or something. I want to make this effect. So how does this work? I don't know. I'm guessing. I thought I could figure this out, so hopefully it's easy to figure out, but I'm guessing it's not going to be easy. So I'm thinking like my original idea for this is that so the black pixels, there's white, red, green pixels, and there's also yellow right here. So my idea was that each pixel has a color component, which is RGB, right? The magnitude of that color component determines the speed of the pixel when it reaches that point. And we just move it forward. So each pixel in image has a speed for a color component. This is what I'm thinking, because I see like, oh, if you're black, this image is probably like black right here. So it moves fast. So black moves fast for all components. White moves slow. And I'm guessing that if you have like red in a certain spot, then you would have red move slowly. So you have like the effect where it looks redder at a certain position. Yeah, I think that's the idea. And you can have colors that overlap. Okay. So if a component is high, then that color moves fast at that position. That's what I think, at least. So you can like initialize the board with random RGB. If they overlap, make it white, make it that color. They each are a class with a position and velocity and speed, not velocity. Well, position and speed, that makes velocity. No, wait, velocity is magnitude. Yeah, so it's only direction. They only move right. Okay, I think that's it. So I don't actually know in Python how to make images. No, I know it's PIL. Programs, projects. I have to be very careful not to show something I don't mean to show. Programs, projects will make your move RGB. And I'll just do PIL. I need to Google like Python make GIF from frames. This is probably PIL. Im.save GIF, save, oh, I remember now. Yeah, we have to make a bunch of images. So we can just make it one frame, I guess. Okay, so vim, art PIL. How do I? Is this full screen? Okay, now we go. Okay, so we have to do like let me just do this outside the environment. Python -m v them. Then we have to do pip install below. And then I can't full screen, so this is the best we can do. Okay, so we have to make the images out of RGB. Have to image draw in. Whoa, this is crazy. I just want to do NumPy. I just want to set pixels in image. Python pillow set pixel color. It's gonna be slow, but I don't really care. Oh my god. im.put pixel. Okay. We can do that. From PIO import image. I hate from. It just, if I, yeah, I don't really care. Okay. Well, we will need to have to load an image though. No, let's just create an image for now. Image.new. Let's just say 200 by 200 pixels with a, oh, I guess this is a background. So this is gonna be black. I think, yeah. im.put pixel. So 4x in range from like 30 to 70. And then we can say 4y in range 130 to 150. We'll say im.put pixel x y, and we'll just do red. RG, what's RG? Is that purple? Magenta? I think so. im.save image PNG. Duration loop. Okay, I think that's fine. So now we can do Python main.py view. What's the MPV? Is MPV? Shoot, what's the command called to view something in Arch? SXIV? It's either MPV or SXIV. I think it's MPV. I don't know. One of them is for simple X image viewer. That's what SXIV means. Okay. SXIV image.png. Yay, there we go. Okay. It works. 30 to 70, 130 to 150. Is that really right? I feel like that should be a lot more. 0 to 100. 0 to 100. Never mind. Okay. It looks like the Gary's mod texture now. Okay, so let's say images is equal to let's say 4z in range 10 frames. Images is equal to this. Images.append a new image. Okay, that should be fine. Images, put this here, just for inspiration. Actually, it's kind of distracting, isn't it? Images is equal to this. We're going to append a new image, and we don't need to append that right now. Images append im, and now we can do this part. So we'll say z times 10. So that should just move from the top left to bottom right. That was good. Images that append. If this is not, yeah, that's fine. Because it's exclusive. Okay. So we're appending the image. We should save this as a GIF. Save all. Append images is equal to images from 1 to the end. Optimize is false. Duration is equal to, I guess, 40. Loop equals 0. It seems weird. Oh, there should be a GIF. I don't know if that shouldn't have worked, should it? PNG. Images 0.save. Otherwise it would repeat. Python image. I wanted to make that a GIF. Results.gif. Now, can simple X image viewer view GIFs? Supposedly not. I know Firefox can. Can we have it do that and not have it break? Oh, yay, it works. Let me do that here. Nice. Okay, so we can just view that. No, I didn't share anything bad. Okay, this looks good. So we'll keep that on the back burner. So our goal here should be to make an image. Okay, yeah. So let's so load the image we want to make the effect out of. We can do this with sys. We'll say base image. Insert the len of sys argv. This should be equal to 2. As an image as an arg. I would say argument. I just don't want to. Oh gosh. As an argument. Okay. So we're passing an image as an argument. We'll say this image. I'm sure there's an image.open function. It was actually in here. Yeah, image or Python pillow image open. Is it a function pointer? No, you can figure it out. Okay. Open argv1. Okay, so now we have the image. Oops, I wanted to run Python. Yep, okay, so now we can say, what's an image I can load? I'm gonna look through my images. I'm looking through a Discord channel for images. Oh, I should look through this Discord channel. Looking through, I can do my profile picture. Oh yeah, I'll do that. Save images, Sophie. I'll go to Pinta. I'll open up Sophie. I'll save as in the correct, you don't see any of this. Programs, projects. move RGB, Sophie dot PNG, and there we go. Oh, how big is this? Oh, this image is 800 by 800. I'm sure this is going to be a very slow process. So even though you can't see any of this, I'm gonna make it 200 by 200. Because I'm sure this is gonna just take all of my CPU process. Okay. There we are. Okay, so now we're gonna Sophie.png. Okay, so I'm assuming that works. All right, so load the image we'll make the effect out of. Turn the image into a speed map. Actually, I don't know how this works. Okay. Each pixel has distinct RGB objects. How is this gonna work? Python likes uppercase for classes. A pixel has a type, color type. This can be a scalar. No, this can be a color. Color is color. Self dot speed. Speed or position. That's what I meant to do. Position is equal to wherever we want to initialize it. Okay, so for each pixel in the image, I'll do that here. Python, hello, get color at pixel. It's probably like get pixel. So we're getting the image, we're converting it. Do we have to convert that? I guess let's just assume it works. For RGB, no, yeah, we'll just do, okay, so for X, Y, sorry, oh my goodness. For X in range, len, there's probably a width function, like Python pillow image get width. IM.shape. Okay. I'm assuming that's width. 400 height width. No, it's rows. So for C in range base image dot shape 1. Okay, so we have each, yeah, we have RGB is im.get pixel at row column. Oh, is this gonna be, is this row column or is this XY? It feels weird to have XY. I'm just gonna assume it's fine. Okay, so we have RGB is that. Shoot, I want to confirm this. Okay, Python pillow get pixel. Yeah, it's XY. Python pillow shape with height. It is with height. But this one's height width. I just don't like it. Okay, so we'll say XY. I want to keep it XY. This is the only part that would change. It doesn't conflict with R either way. Okay, so now we have this. We have the RGB, and we can say we want to make a map of all the colors. Well, this could be a list. Pixels. There's going to be 3 of them for each position. So we can say, we make the list comprehension. For X in range, base, image, shape 1. For Y in range, base, image, shape 0. For component in im.getPixelXY. I think this is the ordering. I may have to reverse it. And we'll say for components, so that's red, green, and blue. So we'll say pixel. Shoot, how do we do that? I guess we can make a little function here. But this is going to return a tuple. This will return I can't do a list comprehension. I'll put that in the back burner. Okay, so I'll just do this. Okay, I know I'm not supposed to do this. Pixels dot append pixel the color is gonna be 255.0.0. No, wait. The RGB just determines the speed of that color at that position. Oh wait, this can be, okay, never mind. I get the idea. This doesn't have to be list. This could be a NumPy thing. I don't know NumPy. For X in range. In my brain, I see how this works. Okay, so for each, this is going to go for each position. Oh, I get it now. Get pixel X, Y, 0. We can do that over 255. Okay, so now we have every position on this board, we have how red it is. So white should be 1, which needs to be the slowest or fastest. White is the slowest. Yeah. Just say 1 minus that. Okay, so this is red, green, blue. We could do this all in one, but we're gonna have a lot of changes to make this. So that's the speeds at each position. And now we need to make the pixels at each position. So I'm just gonna, we'll recreate that thing later. Each pixel has distinct RGB objects. Yeah, that makes sense. Okay. Pixel has the color and position. So we'll say for, yeah, pixel objects. each position on the board is initialized to a pixel object. Pixels for X in range, base image shape 1. For Y in range, base image shape 0. Pixels.append pixel. We're going to append the color and the position. Okay, I get the idea now. The color is going to be red. Yeah, red, green, blue. Okay, so all the pixels are in this giant map right here. We could pre-initialize that to make it faster, but it also doesn't really matter because it's Python. Okay, so now we have all the pixels, we have all the speeds, and now we just need to make the update function. Or we can render it, we can create like a render. Or returns a new image, which I should do this in the other style. Return the new image representing a single frame. Then we don't need to advance the frame. Yep, so we'll create the image. We'll have it equal to the same size. Base image.shape1. This really could have been a constant, couldn't it? Yep. Substitute base image 0 with height. Does that not work? Oh, base image dot shape 0. How is this not correct? Base image dot shape. Is it because regex is weird with brackets? Yay, okay. So 0 is height, width, 1 is width. Yep, so this is going to be width comma height. It's initialized to black. So we'll get each pixel and add it to the frame. Yeah, so we'll need to make some kind of buffer. So buffer is equal to we can't add tuples, that sucks. We can make it a tuple of integers and do bit math and stuff. No, let's just do it. Let's take a simple route. So we have 0, 0, 0 for X in range width, for Y in range height. So it's initially equal to 0, 0, 0. And we can say for pixel and pixels. Pixel.pause. We get the position, we increment that spot in the buffer. RGB is equal to pixel dot color. Yeah, so buffer at x, y. No, it should be y comma x. Yeah, it's row column. Does it make sense? Yeah, I guess row major does make the most sense to me. So if buffer, we're getting for each position in the buffer that, so base color is equal to that. And then we have to say the new color is equal to, because we can't actually add to colors, base color R plus R, or I meant to say 0. Okay, yeah, let me take off my jacket. It's so hot in here. That's a new color, and now we can say it has to be the max, or sorry, the min between this, or no, 255 and that. Because it could be a lot over if things happen. I don't know, should it be a lot over? I guess ideally it shouldn't be, but I don't know how this works yet. New color is that. Base color is that, and now we can say buffer y comma x is equal to new color. This should only ever add one component, because everything can only be one color at a time. Yeah. And now we're going to just create that. Dot put pixel? What is it again? Put pixel. XY is going to be buffer at Y X. So let's do this. Let me just make 3 frames of this. Images is equal to render for I in range 3. It's going to do the same thing 3 times, but I just want this to work. PNG image file has no object shape. Are you sure? Oh wait, this isn't even the right thing. Haha. Cool. Line 18. Okay. Is there any other instances of IM? Oh, this should return. Oh. That should have been... oh yeah, that's gonna be all white, isn't it? Okay, let me just remove them, I guess. So I'll just make random stuff. So let's not do the 1 minus that. We'll just say if x is greater than 100, else 0. Wait, that's the speed. I don't think I did anything with the speeds yet. So we'll do that if x is greater than 100, else 0, 0, 0. Yay! Nice. Okay, so now we have the speeds, we have the pixels. We want to update now. Move the pixels according to the speeds. Or this can just be a 4x in range width, or y in range height. No, wait, we don't need any of this at all because the pixels are stored otherwise. 4 pixel in pixels, pixel.update. Update according to red speeds, green speeds, blue speeds. This does not need to be passed. This could just be a global thing, but I don't know. Should it be a global thing? There's definitely only gonna be one. I don't know, it doesn't really matter. Okay, def update. Self, red speeds, green speeds, blue speeds. See, we're so zoomed in, this is where the end of the line is, but I want to make it fit on the screen. So we'll pretend like the screen is a lot smaller than it really is. You know, ellipses is a real thing in Python. You can have ellipses, and that's like basically the same as pass. That's cool. It's so you can like copy and paste code from online to do stuff. This just doesn't make sense for this not to be inside of a global. It's gonna save. I know we shouldn't be thinking about speed and stuff, but I mean, it's gonna save so much space and time. The speeds, each color component can move. Oh, wait. You only need one of these. We don't have to pass all three. Like red will only move red speed. Yeah. Speed map. That makes sense. Update. We don't need to move all three of them. We just move this single. And then pixel will have the speed it corresponds to. So I guess this is fine. It has the position, it has the color, it has the red beads. Color, position, green speeds, color, position, blue speeds. Render is going to render. Update is going to move the pixels by just calling update. That doesn't need to be that fancy. I don't need to make that a function. We'll say for I in range 3. We're gonna render it and then we'll update. Let me just do this just because it makes a little more sense to me. Frames -1. And then we can update before. Okay, so okay, it didn't break. So update is going to go through each thing and update it. Update. Update day. What's this called? What am I doing? The pixel should move according to the speed. So let's say like max speed. This doesn't need to be right there. At a maximum in one frame, let's say it can move 10 pixels. Okay, so max speed. So we'll say the actual pixels we move, that means pause will have to be a float. The y is going to be the same. X is going to be self.pause is equal to self.pause 1. That's not going to change. But 0, X will change. Max speed is what I called it. Speed map, let's say just speed. Speed is equal to speed map at self pause 0, self pause. I think that should be flipped. Speed map as y is the first index. Yes, it is flipped. That's the speed at the current position. Forward is equal to speed. So if speed is 1, we should move the delta. Delta time, yeah, speed times max speed. 0, we should move 0. Oh, we need to clamp that. So if it's 0, it shouldn't actually be 0. Oh, we can put that into speed now. Like it should be 0.1 or something. I don't like that. Doesn't look very good. Okay, so now we have the min speed, so it should always be moving. So it's not going to get stuck if it's black. This will be at the minimum 1 pixel, so it should move 1 pixel always. Speed times max speed of 10 pixels forward. So we're going to say that plus forward. And we'll need to mod that by the width. Oh, speed map is a property of the function of the cell. Shoot, I hate this. List indices. Ooh, that makes sense. Oh, it doesn't need to be right there. It can be right here. Can we map it? I have never used a map before. How do I even use a map? This one I can show off that I actually know how to use the help function in Python. Function iterable. So can I just do like map lambda a int a? Does that work? 58? Line 58? Ah, okay. I can do the same thing. Lambda a int a self.pause yx. Oh, it works. It actually works. Okay. I wasn't expecting map to work that way. I'm glad it like automatically turns it into a tuple. That's cool. Not very, no, not very good. Okay, let me just put a random here and make it only generate pixels on chance. Like we can just do this. That's probably an easy solution. So it's just gonna be a 50% chance for everything. But let's say 10% chance. Oh, hello. Are you moving? We're gonna render it. We're gonna, oh, we should do images.append. That's hard to look at. Okay, what if we just made it more? Oops. I need to write that down. 7:46 p.m. I should write something. I shouldn't have. Okay, well, I'll remember that. I don't want any cookies. I don't want to click any buttons though, because then I might accidentally show something. So let me just open up what I just opened. I can do this actually. I can do history. I can move it back. Okay, all good. That doesn't look good at all. But what I can do is I can do frames. Oh, we can use TQDM. Yep, so in TQDM, Python pip install TQDM. Oh, that's what I meant to do. I can just do it here. Okay. It's always moving smoothly, except for some of those reds. What if we just made it like 100 frames a second? Or no, that's not frames per second. Huh. It looks like there is color though. Like it's almost doing it. Is it just not getting red, green, blue? What do these speeds look like? Um, we can do flatten the red speeds and then we can sort them to show like what the distribution looks like. Uh, all reds is equal to red for row in red speeds. So I'm gonna say red for red in row. I meant to switch it. I never remember the order you're supposed to do this. Oh, so why did that not work? Oh. Well, there's our problem. Um, if we were to just make it base image dot get pixel xy, what if we just made it this? Do comments work in this way? Guess we'll see. Looks pretty good. That definitely shouldn't be, if we do that over 255. Is this getting like promoted to some weird type or something? One minus that? Oh, wait, min. This should be max. Yeah, that makes sense. Ugh, am I wrong? They're all different, so why are they all exactly one? 1.0. Um, oh wait, hold on. I think there could actually just be a lot of black pixels in this image. So let me just assume this works. Oh, look at that. That's pretty good. It's a pretty good image. If you like blur your eyes a little, okay. It needs to go slower. It definitely needs to go slower. So let's make the max speed like 3. Nice. Let's make the frequency. Yeah, let's make that a property. So chance for pixel probability is 0.02. Chance of making a pixel prob. I don't need this anymore. So I'm glad we confirmed there's just a lot of black pixels in this. Oh, definitely needs to be higher. Is it guaranteed to loop around? Let me just make it like, what's duration? Is this frames per second? Well, this is like 1, 2, 3, 4, 4, 8. It should be, if that was frames per second, that would have been different. Python pillow image save. Okay, duration. The display duration of each frame. Okay, so we can say this is time. I want this to last 5 seconds. So this is long overdue. I should have made this actually displayable on the screen. The duration will be that's the display of each millisecond. So it's 5 for duration times 1,000. That's how many milliseconds. That would be 5,000 milliseconds divided by the number of frames. And that should be it. I'm gonna anticipate this is gonna break if I don't make this an int. I need to remove that. Next time I'll remove it. Three, 4, 5. Nice. Okay. Input. That's fine. I want to choose a different image. What's that? What would that image even be called? Polite looking cat. I want this cat. It's all the same cat. Is this like the huh cat? No, it's a I don't know. I don't want to just search up like cat meme. I like this cat. May I jiggle your balls? No, thank you. That's what I was thinking of. I like this cat though. I'll just say this one. Knapsack solver. Oh, should I show this? Probably not. Um, Desktop, programs, projects, move RGB, cat dot oh PNG. No, I need to be JPEG because now I need to go into Inta. I don't have it open anymore, and I need to open. You can't see this right now. I promise it's happening. Cat dot PNG. What? Oh, this is way too slow. Does not need to be, it needs to be a lot smaller. This image doesn't look like it, but it's actually 920 by 1080. Resize 200 pixels. Oops, you can't see this. Resize image. Look at this. I should just show this from the beginning. Look at this, it looks exactly the same. Just save, there's the save button. See, this one definitely needs more. Pixel prob, I say 20%. How does this look? Looks like dandruff. See, I was originally thinking that like here, we see here there's a clear conveyor belt motion happening where a pixel won't go into the next pixel, but that's not true because we can see the white color right there. So it's not so much that there's just a speed happening. Hmm. It also doesn't help that this side looks like it's generating columns of white. Is that a side effect of the fact this image just has black on the very edge? But it's not exactly what I'm thinking of. I like how my profile picture looked. I can do a warm-up just to make it look nicer. Yeah, let's do that. Let me just add in like a warm up. Um, I feel like how long does it take? One, two, maybe like 2 seconds. That would be as 50 points. I don't know. I don't care. Yeah, the hard part of this is not updating, is rendering. Okay, nice. I think looks fine. What's other images we can do? Cat looks like this. I think there's just too many fine details in it. So like if we were to have an image with less fine details, then it would the effect would be more apparent. What other images exist on my computer? I'm gonna look through Discord. Ooh, you know what I could do to cheat? Oh, that could be a good idea. I could make an image in grayscale. What does that image look like? I'll view it here. Should be like cat.png or something. Ah, but this is already grayscale. It's basically already grayscale. So I can't cheat that way. I was thinking I'd be able to cheat if I made it grayscale. You know what's strange? Why is this section the slowest? That's about as white as this section. This should be darker. This is why I think it might be wrong. What if I rendered the map of speeds? That should just be the image itself. 1 minus base image dot get pixel xy. I can clearly see the ear right there. See the ear right there. This section is clearly slower. Ooh, I think I know what to do. Do I know what to do? Oh, hold on. What if we didn't do this? I wonder how this would look. Whoa. I don't know. It looks kind of cool. It looks so dusty. Radiation storm. This is what I don't get. Why is it so slow for that eye? It's black. It should be the fastest. Okay, this is also another thing. Because this entire row is black, that's moving so fast. Uh, we need to put more pixels on the white areas, right? Okay, so we're gonna make this a function. So let's say for the probability, you're naturally 10% likely to place a pixel on a spot that's full color, and 0% likely, or let's say 1%, because we still want there to be some color. 1% likely if it's no color. So the ceiling is gonna be 10% for 255, 1% for 0. %% for 255, 1% for 0. Okay. Dot get pixel. Is it get pixel? Yeah. So we'll just say this. RGB is equal to image.getPixel. Should be base image. XY. Yeah, X, Y. That should be good. This can go to that pixel. So ceiling for red. If it's 255, it'll be 10%. R over so it's a range of 9% over 255. That's between 0 and 1. Over 10, so that's between 0 and 0.1. Between 0 and 0.1. I want it to be between 0 and 0.9. That's the same thing. 0.9 plus 0.1. I think that's equivalent. Okay, so assuming that we're just doing this for red. And pixel prob should be that ceiling. Okay, let's just make this in terms of, yeah, this is a better idea. And then we can multiply that by the ceiling. Okay. Let me keep that because I think that math is pretty cool. Okay, so we have the red is between 10%, it's a 90% range. So ceiling is equal to red over 255, 0.9. So it's a 90% range. It's going to be 0 if it's 0, 0.9 if it's 1, 0 if it's 0, no, 0.1, so that's 10% if it's 0, 100% if it's 100%. And then we can multiply that by the probability. And we say if that is less than that. Okay, that should work fine. Is there a way I can write? No, I have to use parentheses. We'll just say R seal, key seal is equal to the same thing. Oops. Now, is this correct at all? Too many values to expect. Okay, 3. That is 3 colors. That's 3 values. Is get pixel different from what I'm expecting? Oh, what is this actually? What's the result of this? 1, 2, 3, 4. Why is there an alpha component? I guess it's a PNG, huh? There's still all these things on top. Let me just do this really quick. If RGB is equal to, let's just do red is equal to 255 and pixel crop is equal to 0.1. And this value is 0.1. If red is actually 0, then this is 0.01. Let me just do this really quick. That's what I was expecting. Frames, there's no warm-up frames. And there's 1 total frame. Oh wait, this is actually what I was expecting. Oh wait, this is an issue though. Why are there only red, green, and blue? No, there's cyan there. Oh, you know what I'm missing? This is a lot more regular. This is, we can see there's clear patterns here. You know, what if I just did this? What if I did actually just spawn a line of stuff at the edge? So I like that idea, actually. What if I do that? For X in range, let's do 5 pixels. For Y in range height, pixels.append. So we're just going to put all white on the left edge. What is this music? It's playing like all the extra sounds at this point where I'm at. Oops. So 255.00 at x comma y red speeds. This music is awesome. I don't know if I'm gonna sing it correctly, but right now it's just playing all the extra sounds. Oh, I should have put that right there. I meant to do this. Okay, there we go. Is this gonna be right? No warm-up frames, but let's do our same 100 frames. Oh, look at this. I did Sophie. Interesting. That should definitely be separating. Oh, did I not change that? Hold on. They're all red. That's what I thought. Red, green, blue. Okay, so instead of, let's do 1, let's increase the speed by like 10. I can kind of see it working. Okay, let's put one of these buffers on there. Okay, I have an idea. So we're gonna say, oops, wait. We should be adding. Substitute the beginning with 4. Okay. We won't add new things at the end, but let's add a line initially. Render is going to do that. Update will do that. We'll fix that later. Let's do a counter. I don't like that. We'll do this afterwards. If counter mod spawn interval equals 0, then we'll say what do we call it? Put line? Add line. Spawn interval. This is going to be in frames. This is going to be, let's do it every 10 frames. We'll spawn something. Or we can do like 5 rings. Um, we'll just say this should return true if we should be deleted. Okay, this is the new position. If new pause is greater than or equal to the width, we should return true. Else, we should do this and return false. Okay, so whatever calls update, now it needs to maintain a list of like to remove. If this, then we'll say to remove append pixel. Is there a remove all function, like Python remove all from list? I don't like how that looks. Oh, we probably have to use some kind of like set. Remove each. The easiest way to do this is to just do like for item in to remove. That's probably fine. I don't really care. Type indices must be okay. Hopefully that works. Oh my goodness, it works! Okay, hold on. I think this is actually good now. Let's have warm-up frames be 50. Oh my god. I can't, I'm kind of in disbelief that this actually works. Let's make that higher. Okay. This part isn't actually that big of a deal. See, it's negligible compared to the other part. Look at that. It's exactly the effect. It's literally the exact same effect. Okay, what if we made cat? It looks pretty cool. Maybe this cat is just really specific. I'm gonna ask my oomf if they can find me that image. That looks pretty good. No, I don't know if I can find it in time. I just like how this looks. This is like a pretty good image. What's the other images? Let me go on my Discord server. SpongeBob, Patrick, Squidward, Sandy, Mr. Krab, Plankton, Miss Puff, and SpongeBob. I can't find a good image. I will look up Goku. Goku is here. I will open up Goku in my application. I don't really want to show, I think I have some stuff in my, or maybe I don't. Maybe that's the thing I showed previously in my downloads folder. I think I did. Yeah, I think it's my picture. Okay. This image is huge. That would take me a million years. Oh my gosh. Even auto cropping. Okay, so we're gonna do adjustments. Oh no. Image. The height is just gonna be 250 pixels. Oh goodness. Sophie. Desktop. Programs. Projects. This is move RGB. Goku. Oh, is this the inversion of the colors? I'm pretty sure it is. Goku has, no, the back of the image is white, which I guess is treated as black. This is blue. It should be orange. Interesting. If we were to reverse the effect, oh wait, would this be this thing? Like 1 minus? No. It would be, it would be this part. The pixel should not add, it should subtract. The maximum of either 0, base color 0, minus R. This effect is easiest to see on Goku because we know this should be orange. Ooh. See, look, it's almost good. Okay, actually, wait. If we have that and we make the percentage from 0.2 to like 1.0. Yeah, there's like a million more pixels to render though. Actually, no, look at the speed, it's pretty good. No, it's about the same. Okay. Is pixel prop even being used in? No, it's not. Nah, I don't. It's okay. We can keep it. No, do we want to though? Let's try. If we were to invert this again. The minimum between 1.0 and base image.get pixel. No, wait, should that be that? What I'm getting things mixed up. We could also try to invert that and see if it should be. Although I do think white needs to be the fastest. Well, that looks pretty similar actually. That looks inverted. Yo, this looks awesome. Okay, so we have frames. We have some of the frames, one frames. Max speed, let's speed it down to like a fifth of that. We're gonna have to need to have like 4 times the warm-up frames though. This is literally it. This is it. Okay, so I'll save that as desktop programs, projects, move RGB. We're gonna make a new image called Goku.gif. Okay, so if we were to do the same thing for this Sophie image, look at that. Sophie close. I want to do another one where we space it out more. Like here, that's pretty fast. So let's do spawn interval like 8. Max speed 3. If we do it on the cat image now, because this image just has so much dark colors on it, it's kind of hard to see. That's one too. I don't doubt that they probably very specially designed that image and like brightened it up and stuff. And I could do that, but that's just kind of a lot more work. I think this is just the effect. I think if we're talking about the effect here, this is it. That's really close. Like it, I don't know. I think I like how it looks. What are some other images I could do? I need to think of images. I'm looking through images on my computer. Hatsune Miku. Have some fun, Miku. This looks fun. Okay, I'll do this. Miku. I'm gonna do this. Open. Miku. This one I did realize I do need to show this programs, projects, move RGB, PNG. Oh, that's way too big. Image, resize image, 200 by 112. We can make it a little bigger just to see what it looks like. Actually, no, we probably shouldn't. 250. That was good. Okay. Here it is. Oh, look at that. Well, this right side takes so long to load though. I think it's good. Okay, for this one, let's make the warm-up frames just like 1,000, just so we can demonstrate that it works. I've just realized this needs to be a multiple. They all need to be multiples of each other, or else it won't. The number of frames won't load correctly. But you just need 100 frames for it to look good. I don't know, that one's just too fast. Let me do speed. I don't know, this one I think is going to be too slow. And we may even use a higher respawn interval too, because we did just make it a lot slower. Oh, look at that. Nice. We can keep this one. And we don't need this to be called close anymore, since we're just going to keep how this looks. Nice. Okay, yeah, so I think that's it. So I'll post this code somewhere. Do I want to make this look nicer at all? I guess we can full screen it and then we can edit how things look. Like this does not need to be so much like this. Oh, the things I do for making the code look nice. I'm glad I actually found out how it works. I was not expecting it to work. That looks fine. This needs a space. No, this one does not need to go right there. And neither does the pixel instantiation either. I don't know, there it makes sense actually. Okay. Okay, yeah, I think that looks good now. So I'm going to, that's it. Yeah, so the code is the same. All right, that's great. Here it is. Here's the fruits of our labor. That was fun. I like doing that. So this is what we were trying to replicate. This is what we got. It's pretty much exactly the same. Like, I think that's legitimately just what they did. So I like that. All right. So thanks for watching. I'll put this code somewhere and I'll put the images, I'll post them on my Blue Sky, I guess. Okay. Thank you for watching. Bye bye.